this is what we're building today. We're going to show you step by step how to assemble the newest Cave Pearl logger. This is a much simplified unit that fits within a Falcon tube, a laboratory grade sample tube that we get. The main components remain the same, which is that we have the Arduino Pro Mini 3.3 volt control board with the RTC module, and the power supply in this case is now uniquely the coin cell, which combined with some advanced code modifications allows this to be powered completely as you see it, just the coin cell, and therefore to physically fit into the now greatly simplified housing. In this case, you can see that a pressure sensor has been brought up through the cap, which allows you to have a housing penetration. One of the reasons for going with these Falcon tubes is because of the shape of the lid, which allows for that housing penetration to then be very easily part of the package and sealed off safely.
And that's just sealed with JB Weld.
All right, let's start building.
We'll start with the RTC, and what I usually do with these, first just have a look and see there isn't something I don't need. So for example, this one came with the coin cell already in, and you can't solder it with the coin cell.
Definitely take out the battery.
Yeah, but I usually start with the removals, the things that are on these boards that I don't want, I'll take away. So there's a power LED that doesn't achieve very much for us, so we'll get the soldering tip out and we'll just kick off the limit resistor. And this charging circuit is pretty much useless anyway, and we're going to just jumper that out. So first I'll remove that resistor, again just lifting it off. Then you can run this logger perfectly well with the default 4K EEprom, but we'll take that and replace it with a 64K, which gives you a lot more runtime. Okay, so I'm just going to hold it there, and you don't want to apply too much pressure. You just want to let the heat melt the solder through. I'm just pushing slightly, and it'll lift away when it's ready.
There we go.
Just like that, and you can just brush that away. And so and then I'll go in here and
you want to let the heat do most of the work with a little bit of push.
yeah, these pads are so easy to damage. You don't want to rip the pad off, because then you've broken the connection that you were trying to fix. So now I'll take a leg of a resistor and I'll just bridge this across right here, and that brings the power line. This is the positive power from the battery. It runs along here. There's the battery backup line, and then we're going to bridge that out through to VCC, and this is the connection that'll bring power to the Pro Mini. So this whole pass-through port here is going to be used for the Pro Mini connections. So I'll just put a little flux on that.
Okay, it's tacked down.
And then I just press that and bend it out.
Melt it into the other pad.
Give it a little tug. Okay, we got a good connection there. Okay, so we just bridged the positive power from the battery all the way across to this VCC port here.
You gonna do the EEprom?
Well, first I'll trim these. You see these little posts? These are a little bit long, so I'm just gonna shorten that down so we don't accidentally bridge. And since I'm clipping, I'm also going to take away this 32K pin. When we cut the VCC pin on the DS3231, it can no longer generate the signals that it outputs on this pin. So this pin is essentially going to be rendered useless anyway. So I'll take away that 32K pin, just to remind me it's going to be non-functional. And now we'll go in and I'll clip the VCC leg on the RTC. And this is a little bit tricky to get in there. You just want to clip it and lift, but you don't want to lift the pad. Okay. Alright, so I'm just going to finish this.
Very carefully
Very
on that
carefully.
second leg.
And the reason you want to be careful not to lift the pad is that's also the power pad for the EEprom. So if you lift that, it'll tear out and you won't be able to power the EEprom. So you have to sort of cut and lever it away. And then before we remove that, let's take a look. I can see a lot of solder flux left over. This is pretty common on these cheap EVO boards. Is there? Let's see the other side. Yeah, this one too. It's got a lot of flux left over. So I'm going to give it a bit of a cleaning before we move on.
So this is isopropyl alcohol, 90 proof, 95 proof. You can get it at your local pharmacy. And I know for people starting out, it's always a bit daunting to think about putting a liquid on electronics. But because this is high proof alcohol, this is not water, it's not going to short circuit your devices.
Yeah, I mean, most of the stuff's in plastic or resin packages. It's usually pretty water resistant. When it's not powered, there's nothing to short out.
But importantly, the alcohol solvates a lot of the flux and just the industrial grime that's left on the boards from the manufacturing. And before we got compulsive about cleaning, we had units coming out of the field where some of this just manufacturing crud corroded boards.
Yep.
So clean, clean, clean.
All right. That just gets rid of the flux that was there. Okay. So next step will be...
And actually, for a lot of boards, we'll put them in a sonication bath, but this is an RTC,
Yeah,
so it's not appropriate for this board.
It's got a really delicate little resonating fork inside the chip, and I'd be afraid of breaking it. The Pro Minis, they're pretty tough. You can throw them in a sonic bath, they'll survive just fine, but I wouldn't do that to an RTC or an accelerometer.
A gyroscope.
Or a humidity sensor, anything that's supposed to absorb liquid to do its job.
A pressure transducer.
Yeah,
Because
too delicate.
of the membrane covering, yeah.
Yeah, just, okay. So
All right.
let's give this a little zap here.
A little bit of hot air
Okay.
to get rid of any residual alcohol.
Before we do this, we should mention this is optional. This is a perfectly functional 4K EEprom. And that's 4,096 bytes if you were saving a regular 2-byte integer. You would still be able to get 2,000 readings in there. So if you were doing 15 minutes, 100 a day approximately, you still get 20 days of data stored in that if you just use the default. We want them to run a lot longer, so we'll put a couple of 64Ks on there. But this is still totally functional. You don't have to do the upgrade.
Yeah, I mean, almost all my monitoring is at 15-minute intervals, which is 96 readings per day, approximately 100. So really this is just a size factor. How much data do you need to have before you're able to download your units?
Okay. And the trick here is to not pull. Again, you don't want to lift the pads. I know I've said that a few times, but I've done it so many times. When it's ready, it will just lift off with no pressure at all.
So you're just heating the solder that's on that EEprom chip to the point that it is soft and melts, and there we go.
There we go, and it just fell away. And that's what's supposed to happen, because we want those pads to be okay.
That is blowing, in case anyone's wondering.
Yeah, I don't want the... Oops, still hot. I don't want to cook the poor RTC chip. In the process. And you can use your finger. If it's cool enough to touch, it's probably fine. So now these little these EEproms come in strips that people have cut from reels.
Let's see that. Hold on. So yeah, these are sold in great big long strips because they're designed for being used and installed on assembly machinery by robots. And they're surface mount, so they're small, but they have all this strip packaging on them.
We're going to put 2 on. This is where my old eyes get into trouble because these are quite tiny.
Don't be shy, people, about wearing your 3-time magnification glasses. It makes this job so much easier. Also, it's good for safety. You'll see at some point during this assembly when components go flying off. We like our eyeballs.
Alright, so I'm going to have to move this a little bit so I can get a good angle on it. And I have a wooden block here off camera to steady my hands because this is some pretty tricky soldering. Okay, so that little dimple there is the pin 1 orientation, and the text is right side up as I'm holding it here. And this is the orientation that the original chip was in. Both chips are made by the same manufacturer, which is really nice because it means that all the pins align. They're both AT series EEproms. And the first 3 pins from that little dot, 1, 2, 3, those are address pins, and we don't need to solder them all. We can just clip a couple, because anything that doesn't get connected will be internally pulled to ground. And at this scale, anything you don't have to solder is a blessing because it's such a finicky little job. There's also, up on the other side, the second pin in is the write protect pin, and it'll get pulled to ground internally as well. So I'm going to just cut that to save me from having to solder.
That would be the flying metal.
Yep. So the next step is to pre-tin these. You don't want to bring something down to the board and try and tin and connect at the same time. So I'm just going to put a little touch of flux on these pins.
Using a sacrificial resistor yet again.
And they're so small, just the slightest touch will do it.
What's nice about hand holding these is that you're also temperature checking them at the same time.
Ah, yes, yes.
Yes.
If you can hold it, you're not cooking it. If it's too hot to hold, there's a good chance you might be damaging the poor thing. So my rule of thumb is to use my thumb. Sorry, couldn't resist. Alright. Well,
you could have, but...
So I just give that a little tap. Again, those pins are now tinned. So the hardest part is the start. And I usually tack down 1 pin. It's always the same pin first.
These guys are so light, they tend to fly off, so you want to have your RTC board nearly flat in the vise while you're doing this.
Mm-hmm. So you let me know if that's focused.
No, we're good.
Okay. And I have my hands on the wooden block here to try and steady myself because this is quite tricky.
Let's get that first one tacked down.
Yeah. Alright, so that's the first corner. And what I'm really concerned about is melting the solder that's already on the pad, because that's the hard part, is getting the connection to the pad.
Now that first tack came in pretty well aligned, but it's pretty common, like you get the first one tacked down and you might need to do a little bit of rotation adjustment on this EEprom.
Mm-hmm. So I'm holding this and then I drag it towards the chip. And it's okay if there's a little extra solder on the first one, because we're going to be stacking another one on top. So then I'll do this corner here. Okay. I'm just going to bend it a little bit closer towards me here.
Now you can tilt it because it's tacked down.
Yeah, so that one's tacked, and this one is tacked. Now I want to get this one soldered. And this is the other I2C bus pin here. I think that's okay. Might have to put on 2 pairs of glasses to see. That looks clean. Looks clean. Oh, I bridged it. Okay. Well, that's not bad actually, because I can show you the 2 techniques I use to undo a bridge. So this is a mistake, which is actually fairly common. If you're lucky, you can break the bridge with the tip of the tweezers. Let's see if I can do that.
It's always daunting when somebody's starting out, the idea that you're going to be soldering the legs on IC chips.
Yeah, I don't think we'll ask your students to do this on their first go. This is a little hair-raising even for me. Okay, so you saw how I poked the tweezers in and then just sort of pulled it away.
Created the channel to separate the bridge.
Yep. Yeah. So the bridge, I managed to get it undone. But if I hadn't gotten it undone, So I would have just used this stuff and pressed that into place on the bridge, and it would have pulled the bridge away and we could have started again. But we got lucky and I was able to just sort of break it with the tip of the tweezers. So that's the first one in place. We can stack another one right on top.
Let's just have a quick, can you visually examine that a little bit closer? Just make sure we're good.
I think we probably need to redo, now that I'm looking at it at a proper distance. Let me give that another pull.
Pause and look is always a good thing.
Well, this is off camera, but my face is about 5 inches away from this damn thing.
And you're wearing 2 pairs of magnification glasses.
Shush. Yes. The key is getting it on the pad. And I think we've got that there. Good. Okay. So yeah, I'll go back down to 1 pair of granny glasses. Right, so the next one that goes into place, we want the legs to go straight down. So my first step here, it will be to remove what we don't need, and then
let's just explain a moment. This second EEprom is literally going to be stacked on top of the first one, and so that's what we're aiming for.
So just as before, I find a little divot. And these first 3 pins are the address pins. This one we left 1 on, and the pull-ups here will bring that to a 1. So the last 3 digits of the I2C bus will be 1, 0, 0, because we didn't connect these two. The one above it, I'm going to save myself 1 more soldering step. And I'm just going to clip all 3 of the address pins. And so this one, the last 3 digits of the address will be 0, 0, 0.
It's physically setting what the address is. It's almost like saying dip switches.
Yeah, essentially it is. And so this is the write protect. Again, gets grounded internally, so I don't need that. And then I'm going to bend these pins so that they're pointing downwards.
Importantly, the tool change. Those are needle nose pliers.
Yeah.
Do not want to be using your side snips for doing these kinds of bends, because too easily, too often, you inadvertently score the metal, and it then breaks off.
Yep. Okay, so now we tin the little pins just as we did before.
Hand holding.
Yeah.
A little bit of flux, a little bit of tinning.
Okay, so now we have tinned and straightened pins. So tack 1 corner. If it's in place, then I can start tacking the rest. Okay, and the trick was I went down to the pad at the bottom, heated everything, and I pulled it up. So now we rotate around, and we do the same on...
Visually check that it's nicely aligned.
Yep. So we've got decent alignment on that first one. So I'll go to this corner, a little more. Usually you can have a little more solder on your iron when you're doing these outside corners, because you're not going to bridge anything. Okay.
We cut off the other 3 legs on that outer side, so...
Oh yeah, so I don't have to do this one. So on the bottom one, this leg was done, but there's no connection to make there.
Back to the inside, which is harder. Less room.
I'm going to start again on the far outside one. You know, always buy twice as many of these things as you need, because you're gonna muck up the first few. I know I did.
It's pretty common. I think a batch of 6 is a good number to make at a time.
Yeah.
Once you get going,
but
after you know you're doing good.
Assume that you're going to mess up these little components.
But even with experience in batches of 6, you can commonly end up with.
Alright, this is the tough one. Is it in? So I'm just going to try and bridge that second one there. And if I'm lucky, I pull up. There we are. So that worked really well. Those two are now bridged from the pad all the way along both legs. This one's pretty good. I can give it another touch if I want. Okay. Well, why don't I just move that around? So it's done now, but we need to inspect it so I can level it, and we'll zoom in on that one side. This is the tricky side.
Yeah, so now we're looking at the inside. Okay, so we can see that those three legs are, the first EEprom is soldered in, and the second one on top is now over soldered on top of it.
Okay, should I turn around to this
Yep.
side? All right.
And here the bottom one has that first leg soldered and the fourth leg. And the upper one, we clip those three, and so it does not have that first leg.
Yeah, that upper one will have the last three digits as 000.
Mm-hmm.
The ones that touch the pads are pulled up by this set of pull-up resistors.
Yep.
Okay, I think we're probably ready for some conformal coating here. Since this is probably in view, I don't know if you can see the serial number that's on these. It's worth mentioning that these chips come in variants. This is an SN, which is the industrial one. Has better accuracy ranges for its time drift error. There's an N version, which is also pretty good, and then there's an M variant, which is much worse on its temporal drift, but I think it's more resilient to impact. It was the military version.
It's more ruggedized.
Yeah, they kind of end up sending us all of them. You know, when you get them from eBay, you never know which chip you're going to get.
Yeah.
Okay, so let's put some conformal coating on this and set it aside while we work on the Pro Mini.
So conformal coating is nasty chemicals. Ideally,
yeah.
you want to do this outside. You want to do this in the best ventilated area that you can get to. But it really does indurate the units, especially if you have a very small leak or some sort of humidity coming in. It will save a logger. It's important that you do not put the conformal coating on any contacts that actually need to be electrically used. So do not put them on the actual header pins. And in this case, do not put conformal on these pads out here, because we're going to be using those.
Yeah, I'm just going to be covering the chips really, and the idea is there's probably still some flux left under these chips somewhere, and I'm just sealing that in so it can't absorb moisture later and rust on us.
Yeah. Flux is hygroscopic.
And the conformal also glues the pins a bit, so it's not bad for helping the two EEproms we just stacked become a little more robust. Okay, so we're done working on this board. The next thing I usually do is test them, and I'll have a breadboard version ready. So this is just a breadboard version of our logger with the I2C bus broken out, and so I can just plug this guy in on the breadboard.
You don't need the battery in because that'll be powered over the UART.
Yep. And so we'll be, first I'll set the time with the set time application. It's up on the GitHub repository. Then I'll run Rob Tillart's bus scanner and check that the two EEproms show up. If you don't have the two that we've included, you will still have the original 4K, and it'll show up on the bus at 57, and then the RTC shows up on the bus, I think it's address 68 hex, I can't remember exactly, but you should see both chips show up, and if it doesn't show up, then it means that you didn't get one of your soldering points done correctly.
Or you have a bad component.
Or you have a bad component. After the bus scan, we'll just read the time and check the temperature. I've noticed on the Dash M chips that the temperature register can be way off, like 5 or 6 Celsius off. I think they're B versions that ended up on the eBay gray market. But anyway, you want to test, will it take the time setting, will it report it back, is the clock advancing, and does the temperature look normal?
Yep. Okay.
Okay, so we're just going to assume that this is good for the video so we can progress.
Set that aside to dry.
Yep.
Now we move on to the Pro Mini.
Pro Mini.
What are we going to do first, Ed?
Same as the other part of this logger, we're going to start with our removals. And just as before, we've got a power wasting LED indicator that doesn't need to be there. We'll kick off its little tiny limit resistor.
Mm-hmm.
We'll remove the regulator because we're running unregulated from the coin cell.
Mm-hmm.
And we'll pop off the reset switch.
What's the value of removing the switch?
We're stacking up some sensors. I usually use these pins here for the built-in sensors because the ICU, the interrupt unit that generates really accurate timing, is on pin D8. And so we're going to be stacking some components here. And it just makes it hard to route everything if that switch is still left in place. So
plus, as people will see, like with the twisted assembly of those sensors, I could imagine you could, as you put it into the housing, inadvertently press the switch, and that would cause problems.
If you want to heat shrink things, the heat shrink can switch. The other thing is that
so it's really kind of like just a packing space issue.
We've also got a serial handshake when these loggers start up, so that you can't really restart them with just the reset switch anyway because you didn't do the serial handshake.
Yeah. So just to mention, so that has a little bit more of a beefy connection on the side, and so Ed just grabbed the side snips and just snipped that, and then levered it upwards, and the other side broke off mechanically.
This is the tricky one. You don't want to dig too deep. You just want to get the leg.
So this is a surface mount. Let's see if I can get in a little bit closer. There we go. Okay, what are you doing?
I'm going to remove the regulator because we're going to be running off the coin cell. And you have to do this carefully. You don't want to dig too deep and cut the traces under the regulator. Mm-hmm. I'm just cutting the legs and I'm lifting it gently. And once you get to this point, you can just wiggle it back and forth.
The stress on the other legs mechanically breaks them.
Yeah, they can just be wiggled off at that point.
Bye.
So again, the key is not to just, don't go in there like a shovel. You don't want to cut all the other little traces. You just want to lift that leg. And then the last thing we're removing is the LED resistor.
Okay. This is a surface mount.
Very tiny one.
Yep.
And I'm not going to push. I'm just going to let the heat move through it. And when it's ready, it'll go.
There we go.
Yep. Okay, so those are the removals. Next step is to put some header pins on there. I have to lay that down for that. And these pins are pretty beefy, so it might take some time to heat up the pin before you get the solder to flow. When you're done, pull the soldering tip up and away from the header pin.
Mm-hmm. Nice Hershey's.
Yeah, so you get a nice cone.
But you also want to fill the pad. It's that happy in between.
Yeah, these aren't very heat sensitive, so when in doubt, hold the soldering iron in contact a little longer.
Oh, but for people starting out, just know it does happen that you can apply too much heat and the black plastic on the other side starts to melt.
Oh, yeah, okay. Yeah, it takes practice.
It does. It's pretty common when training people. The first one comes out a little bit fugly.
Mm-hmm.
And they come back and they're like, "Can I have another one, please?"
Oh, that never happened to me. My first ones were perfect. Okay.
Okay, pause and inspect.
Yeah.
How do we do?
Yeah, it looks all right to me.
Oh, okay, it's a bit hot. We're going to want to wait.
Yeah, and I'm going to trim a few of those just because later on I want a little more headspace to work with.
Yeah, they're okay.
Okay.
It passes Q&A.
Yeah. So these two are ground. That's the VCC line. These three, I'm just going to trim them flush, just because when you see later how we join the two parts, having a little space there is useful.
More flying metal.
More flying metal. And then, of course, we always have to clean. Okay, so now we'll go back onto our pan of ice here. And we're going to use an old resistor to bridge the I2C bus, this A4 and A5 connector. We're going to bring those over to the end beside the VCC and ground lines so that they can join to the RTC pass-through port. And this is a fairly easy job because you can just poke the end of the resistor in and bend it away from you.
Usually physically just sits there.
If you're lucky. Sometimes it wanders, but you can just melt it and bring it back. And then we'll heat up the whole thing. Let the solder flow into the channel.
Just cut off the resistor, but now you have the resistor on the other end of the wire, which you're going to use for the next hole.
So that wandered around, but I'm just going to do it and push it back into place. So I'm pulling on it.
That is now trash.
Because we have to cross these over under the board here, so I'll just cut a little bit of the, this is 1/16th tubing. I think it's the smallest you can get. Nail that down. And to align with the pass-through port on the RTC, this one has to be furthest out. This one crosses over, and then I just press them down.
We're going to leave them just hanging for now.
Yeah, those will get bent up and routed through the pass-through port. Okay, so that's the I2C bus. Now we'll start adding the components on the upper side.
All right, what are we going to put on this?
Well, I was going to add a thermistor and an LDR, and that involves actually adding 5 separate components. I've got an NTC, and that's the LDR. And we
NTC is negative temperature coefficient.
Yep.
Thermistor.
And I've got a couple of resistors.
And the LDR is a resistor, but it's light sensitive.
Yep. And I've got a couple of other supporting resistors. One is a 10K reference. Both of those resistive sensors will get compared against that. And this is just a safety limiter for pin D8, the timing pin.
And the good resistors stay in their packaging so that you know what they are.
Well, when they're this small, I'm using 1/8 of a watt resistors here. I like them because they're small, but they're really easy to cook by accident. If you're just starting out, use the regular 1/4 watts. That's the 10K reference resistor. Okay, next one will be our little NTC.
Why are you mounting them so short to the pad?
So that they can be low profile. I want the final result to be slim enough to go in those tubes.
Just for people starting out, you could give it another couple millimeters and it'd be fine.
Oh yeah, I'm just trying to do this low profile. As I said, I'm also using the small resistors, which are a bit dangerous if you're just getting started.
I guess I'm just commenting that if you're starting out, I mean, a bit more width is still, you'll still be able to pack it probably.
So I'm just going to twist these together here. Okay, and then we'll put on the LDR. And the LDR is a little trickier because it has a very thick lead, and I'm not a big fan of thick lead components because they tend to cook even faster.
Yeah, I mean, look at how thick those wires are compared to.
Yeah, so
Doesn't take much.
Okay, so that lead's already tinned. I'll just bend it over. You can bend it back, but I find that having it sort of just hold itself in place.
Like pointing out from the end of the board.
Yeah, I'm going to bend it back up after, but this just gives me a free hand.
That's the wooden brace coming in. So just to make this nice and steady, the right wrist is on the wooden block. There's the advanced cooling system engaged.
Yeah, and the default temperature sensor. Which, okay, so we didn't cook it. Hopefully, we'll see when we do testing later on. And I'll put another length of heat shrink tubing on the leg of that LDR. Okay, so that little bit of heat shrink was just there to prevent it from grounding on the back plane of the Pro Mini. So those are all connected to a common point. And the last component in this little sensor set is a capacitor.
So out of all of those, the capacitor is probably the most heat sensitive.
No, it's the LDR. I've cooked the LDR quite often by accident, by just holding too long. I mean, they're all heat sensitive to a certain amount. You want to be careful on this. Now we're just going to flux that bundle and join them all together. And we'll cut away the excess. So those are all joined at a common point. And the method that we use is basically you successively charge the capacitor through the reference resistor, the NTC, and the LDR, and then you compare the readings, and that lets you determine the resistance. Alright, next thing we'll put in here is a jumper on D2. This is the alarm line, and so this is the interrupt that has to wake the processor, so we're going to connect that to the RTC's SQW out. So I'm just going to put that jumper in place.
And using nice multi-strand silicon jacketed wire on this makes this so much nicer and easier.
Yeah, this is just a scrap that I had left.
No, I know, but when you want to flex these wires across, it's nice when they bend.
Okay. Well, you could have used a resistor leg here too. I have done that as well. Okay. And that's approximately where that's going to get routed to. So we'll pop it over and clip the tails, and we'll also examine the soldering, because sometimes it doesn't flow through as nicely as you'd want.
Pause and inspect.
Yep. So I can see that the capacitor doesn't look pretty, doesn't look like as nice as I'd like there, so I'm just going to touch it up from this side.
Okay.
Okay, and I think that first resistor could use a little touch up as well. If you want, you can do all of them. You know, just to make sure.
Well, yeah.
Okay. So
They have to be functional.
yeah, they don't have
You don't
to be
want cold
pretty.
solder joints.
Yeah.
You want the pad nicely wetted.
Yeah. And there's a little tail here from that alarm line jumper. I'll just trim that down. Trim that a little. Okay. Next component to add is the indicator LED.
Before you move on, I just want to point out that this twisted bundle with the sensor wires, join them all together, is literally just floating free on top of the board with the cross wire from the capacitor going down to the capacitor. So basically that bundle cannot touch down and short circuit on the board because it's being held up by the wire.
Good point. Why don't we, I'm not sure I had the routing correct there. Let's just make sure that the wire goes under the capacitor.
Mm-hmm.
Just lift it a little bit. So now it cannot touch down because the wire is definitely...
Mm-hmm.
Before we put the LED in place, I'm just going to check that there's no tails. There's a little tail there.
Mm-hmm.
Just get rid of that. The other one's pretty flush. And again, you can inspect the solder. If you're not happy with something, just give
Now's the time to fix it.
give it a little touch. Just to make sure that that joint was good and connected there. Okay, so this is a common cathode LED, and it's an RGB, but we're not going to use the red channel. I always leave the default indicator on these boards because the bootloaders assume it's there, and it's often quite useful to know if you're having a problem with a bootloading loop.
It's on pin 13.
It's on pin 13, and if you use another indicator LED for your air state or your red, the bootloaders won't know it and they won't flash and tell you what's going on. So I usually locate the red pin, and you can do that with a coin cell. Coin cells have enough internal resistance that you can't really hurt the LED turning it on. So there, that's the positive telling me that's the red LED. If I turn it the other way around, we can light the blue and the green.
Mm-hmm.
Okay, so that's the red. That's the one I'm going to cut, because we already have a red indicator on the Promini. Okay, so this one, the longest pin, is the ground. I'm just going to poke it through A0 to A2. Okay, so I usually repurpose these pins for the LED because I don't use the internal ADC that often. We still have A3 available if you want to do an ADC reading, but I rarely use them. I usually connect I2C sensors. So I'll push it through.
You want some length, you're going to bend it over.
Bend it over, yeah, right there.
And the form factor on the LED head is such that those wires can't touch down on anything, so...
Yeah, and I use the diffused ones, easier to read, because once we bend it over like this, we're reading the LED from the side. The first pin, you don't have to worry too much about the position. See how it's shifting? I'm just going to push it back down into place, and then pull the iron up. Again, you're trying to get that little cone shape, so you pull it up along the wire, and once it solidifies, it's held in place for the next two. There's our indicator LED. I'll just flip it over and trim the legs.
Down.
Yeah.
It's worth commenting that side snips that you use for cutting header pins and for cutting wires like this take a lot of abuse.
They do. They're disposable. You go through them.
And the ones that you use for cutting the little legs off of the IC chips are the nicer ones.
Yeah, I save a good pair for just for that.
Gentle jobs.
Alrighty. So that's the Promini board prepared. We can bring out the RTC again, and the next job will be to bring them together. I'll have to add a couple of legs to this to extend the power rails. So that's our I2C bus. Now we're going to add some power lines.
Using yet again the sacrificial resistor wire. And you're drawing that up along the length of the wire just to tin it.
No, in this case it's just strength. I want that joint to be strong enough to pull on.
Notice the compulsive little tug.
Yeah, you just give it a little tug. And I usually put a little hockey stick. These are both grounds on the Pro Mini, these two end ones. And just for a little more structural strength, I'll solder to both of them. So I'll put a little hockey stick on there.
It's a bit close to the third pin.
Well, those are both grounds, so you don't have to worry too much about them.
No, I know, but we have to thread them through the holes on the RTC, so we want the spacing to be approximately correct.
Okay. So there's our 4 I2C bus connections that are going to jump over to our RTC.
All right, now we make the sandwich.
All right. Our conformal has dried, so we're going to put a little layer of heat shrink, or rather
Double-sided tape.
double-sided tape on that so that we can bring the sandwich together.
No, this is 30-pound 3M double-sided tape. Okay. So placement is side to side and going across the chips.
Yeah, the chips are the high points, so they're what's going to come in contact with the Pro Mini when we join them. And this is usually the tricky part. It sticks to itself better than it sticks to anything else. Yeah, this is just how it is.
There we go.
Anyway, okay. So now, the idea is we're going to thread those 4 wires through the pass-through port on the RTC, and the long ones are pretty easy. But the tricky part is getting the
number 3 and number 4 in there.
Yeah, and remember we crossed over those wires. Here we are. Okay, so those are just through, and then you need to look from the side and check your sort of physical alignment.
Yeah, make sure the two sides of the two boards are neatly aligned. Like, you can't have one skewed, because if they're too far skewed, they will not slide neatly into the tube.
Yeah. So what we've done here is, I was doing that by feel. I could tell I had alignment just by pinching the parts.
So basically, you're pinching them from the sides to make sure that they're aligned. Yeah.
Yep. We're slightly out.
Don't press down on that double-sided tape until you have your alignment.
Yeah.
So you gotta get the 4 pins through the holes, and you have to have the alignment, and then you squeeze.
Okay, and so now we're gonna solder those 4 wires. Sometimes I'll give them a little tug just to make sure they're through. All right. I'm just going to run some tin up these wires because they're going to be used as attachment points. The ground and the VCC lines will go to a capacitor. Okay, so that just tinned those 2 long wires. You'll see why in a second. So we can trim the tails of the SCL and SDA lines, and then we'll bend these into place, ready for the capacitor. The little coin cells that are powering these loggers don't have a whole lot of current reserve, and so putting a capacitor on the back here keeps the voltage droop safely away from our triggering our BOD on the processor.
The brownout detection.
Yeah. Okay.
All right. So.
Another surface component. Yeesh. This one's easier to deal with, actually.
I find these ones harrowing. Get out of the plastic. And remember to train yourself. When you drop it, do not roll your chair back over your component.
Don't even say it. Don't tempt the gods. Okay. Alright, so I'm going to pre-tin this little surface mount capacitor. This is a 220 microfarad. And it's the highest voltage I can get is 30 on these. And the higher the voltage on your rail buffering capacitor, the lower the leakage current. And I find these are, if you can get the 30 volt ones, here we are, that's a little solder blob.
And held, so you know the temperature's not cooking your capacitor. These ones do go poof and
let
the magic escape.
Yeah, the thing that makes these go poof is getting the polarity backwards. And so there's a little indicator bar on the positive side.
Okay, so instead of a notch, we have a bar.
Yep.
Anything that's has an orientation typically has some form of physical marking on it.
Yep.
Sometimes it's longer wires, as we saw with the tricolor LED.
Yeah. Anyway, this is going to be a little tricky. I'm going to have to tilt it to get the angle. I'll do the one side first. And because both the wire and the capacitor are tinned, this isn't going to take that long.
No, but you need to get in that little snuggly space around the coin cell holder.
Yeah. Okay. There. So that's that side. Flip it back up and do the same thing again to the other side.
Done. And just push it down.
Trim the wires and push it back into place.
I would have pushed it into place and then trimmed the wires.
Okay, and then the last thing before I run away, I'm just going to...
But functionally, you want the top of this capacitor to be equal to approximately the top of the coin cell holder.
Yeah, when you put the heat shrink around the last step, it's just a nice, convenient place. Yep. So just clean off the flux.
Alright.
Okay, and then the final connection we have to make is over to the alarm line. This is the D2 interrupt pin, and this is the alarm line. And the other four are the I2C bus. So I'm just going to move this pin out of the way here.
You move it or cut it?
Both.
Don't use your needle nose.
No, I'm cutting it too.
Oh, okay.
Right? Just so that this little alarm connection is off to the side. This is going to be where we hook up sensors like the BH1750 or whatever I2C sensor you want goes on those four. But this is just the alarm. So I will...
It's nice to twist that off because then your multi-strand comes nicely twisted.
So there's our twist. Both of these things need to be tinned before I bring them together. So I'll put a little flux on the pin and a little flux on the wire. Looks like we have a whisker there. Okay, so they're both...
it popped. It popped off.
It just, I hadn't joined it yet. I was just tinning them and then grabbing my tweezers, and so now we actually join them together. The next step is to bring it upstairs, connect it to the UART, I usually run a few tests on it. Again, I'll do the bus scan again, just to make sure we're still getting the RTC and the EEproms, if they were added, communicating. Run blink, of course, and since we left the default LED, the little pin 13 LED on there, blink will run without any changes. I'll also change the pins for blink and set it to input pull up and test the LED.
The blue and the green, at least.
Yep. And if we were attaching a sensor, in fact, we have one around here somewhere. Where's the other logger?
There we go.
Yeah, so again, this is where we started. What we have here is the one we've just completed. And I'll run it through some tests. I won't put the final heat shrink around this until I've had it fill up the EEproms. I usually run it for 3 or 4 days. And that also gives you a chance to test the sensor, especially if you've mounted the sensor in epoxy like this one is. You know, you want to run your burn tests with everything connected. I wait until...
How often are you finding that the EEproms have bad...
EEproms are really robust. They're rarely a problem. However, the Pro Mini is probably the most common issue we run into. Is a lot of these things have fake 328p chips on them, and they won't sleep below 150 microamps. Normally, even with the sensor connected, if it's a decent sensor, you should expect these loggers to sleep around 2 or 3 microamps.
Okay.
And if it's up at 150, the first suspect is you had a bad chip on your Pro Mini. Once the unit has passed the burn-in tests, then I'll add conformal to this upper surface. You see how this upper surface is still not conformal, even though we did the RTC? I leave it naked until I'm sure I have my final configuration. Then I'll conformal all of this stuff and give it a wrapping of heat shrink. And this is 1.5 inch, I think. I have to go check. It's 1 to 1.5 inch. And then you cut away the area, put the coin cell in.
It's been really nice with this build assembly, like turning them into like little chiclets, in that they slide neatly into and out of the tubes.
Yeah.
You know, it's probably avoided a lot of problems with, you know, maybe just catching the LED and having it bend backwards. The next thing you know, that the bend fatigue you caused, you know, a break. But
yeah,
yeah,
it's a nice little package, and two primary components. With a little bit of practice, you can get quite quick at the soldering steps, again, as outlined on the blog. That's it.